Hey, WTUFO fans. If you like the show and you want it to continue existing, head to patreon.com/WTUFO and support us for $1 a month. No special stuff, no gatekeeping. Just support the show for $1 a month to help it keep existing. Patreon.com/WTUFO. Thank you very much.
What the UFO? I'm here with Kevin Knuth. Dr. Knuth, it's an honor to meet you. Hello, sir.
Hello. Thank you for having me.
Thank you so much for being here. If anyone doesn't know, I've got a long bio for Dr. Knuth here. He is a full professor of physics at the University of Albany. He's the editor-in-chief of the Entropy journal. He's a scientist at UAPX. He's on the board of the Sol Foundation. He's an associate of the Scientific Coalition for UAP Studies. He's on the board of the Society for UAP Studies. He's an affiliate of the Galileo Institute, an associated member of IFEX, the Interdisciplinary Research Center for Extraterrestrial Studies in Germany. And he's a former NASA employee in addition to studying myriad wonderful physics properties over the past 20 years, where he's been teaching at University of Albany. So did I get everything just about right there, Kevin?
Yeah, where do I find the time? Oh my God.
It's an extremely impressive resume. And we were speaking a little bit offline about how cool it is that you've got all the UFO Pokemon. You're connected to almost every major organization that's studying this stuff. So maybe we could start with a little bit of a comparison. How do you feel about the work that these different orgs are doing?
Oh, that's a good question. And to be fair to, my colleagues, we're all connected. We're all well connected. The situation's actually quite ideal in that we are all working together, to understand, UAPs. And if we're not doing it on the surface, we're doing it below the surface, so it's not always obvious that we're working together. And meanwhile, the organizations have different goals, and that's also good. You can't have one organization taking on all of these goals. There would be massive sub-organizations, and that's kind of what's going on. I mean, we're all so well connected at this point that all these organizations are just doing different things. So UAPX, which is my main focus, and I've been with UAPX now for 5 years, I think. Maybe a little more, maybe 6 years at this point.
Cool. And that's as long as it's existed. Were you a founding member?
Existed, yeah. I'm not a founding member, but I was shortly after. It was founded by Kevin Day and Gary Forries, and so we focus at UAPX. We focus on collecting scientific data on UAPs. That's what we're interested in. And our focus is very similar to the focus of the Galileo project, which is the one run by Avi Loeb at Harvard. They're focused on collecting data as well. Wes Waters is their lead scientist, and he's excellent at instrumentation. And so we often compare notes. How do you handle this? How do you measure this? And, we're helping each other, which is really ideal. And that's really what goes on with a lot of science. It's why it's good to get scientists involved. It isn't like a secret government organization where you've got this group of people who are studying this, and there's 3 people working on it and they can't talk to anybody. And then you've got 3 people working on this and they can't talk to anybody. So nobody knows anything. That's not what's going on here at all. We all communicate with each other regularly. That's cool. So it's very good. And, SUAPS, I'm just summarizing what they're doing. I'm going to miss things and maybe mischaracterize slightly, but, SUAPS, the Society for UAP Studies, which I'm on the board of, they support a journal called Limina, which is focused on UAP studies. So that's excellent to have a scientific journal that we can go to. It's good for us to publish in other journals as well, if we can do that. But Limina, which is supported by SUAPS, is an excellent work, and they also focus on education as well. They have organized classes that you can sign up for online classes on UAPs, which are my colleague at Albany, Matthew Shadagas, was teaching a class this last semester on interstellar travel and propulsion. So,
wow.
Yeah, so it was great fun. I mean, it's great to have these opportunities, and I think this, and I'm board of the Soul Foundation. They're more interested in informing governments and communicating with governments and officials, and so they handle a lot of that work, which is good. It's hard to do that at the same time that you're collecting scientific data. You're out in the field with your instruments, right?
That's right. They seem like they have the slickest public-facing operation right now. So Soul kind of is trending toward the communications quadrant of this challenge, and Society for UAP Studies trending a little bit more toward the academic and educational quadrant. And then UAPX and both the SCU, the Scientific Coalition for UAP Studies, are interested in gathering data and then doing science on this data.
Yeah, UAPX and Galileo are focused on collecting data. SCU has I don't think they have a branch collecting data at this point, but they have worked with old data and worked on cases. So they'll pick prominent cases like Aguadilla or prominent problems like UFO incursions at nuclear weapon sites or nuclear sites, and publish, they do studies and publish extensive papers on these, hundreds of pages of paper, which is really wonderful to see that work being done.
We just had a walk.
You get Arrow produces something and they produce 10 pages of stuff that comes off of Wikipedia, but SCU was actually producing excellent work.
And not to time date us, but I heard a rumor that Arrow was maybe going to release some documentation about what they thought of the Aguadilla case, and SCU has famously covered that in some detail. So
yeah, they've covered in detail. So yeah,
it should be interesting to see those comparisons. We just spoke last week with Rich Hoffman, who walked us through a bunch of these papers and said that you would have some good insights as well. I was really struck by their analytic capabilities, and as you said, collating old data. It looks like they were building a database and going through old files. What do you do with SCU? What have you contributed research?
I've consulted with them and we've talked about projects. And in fact, have been working with Rich Hoffman and Robert Powell this last year. We have a paper coming out on the history of the scientific study of UAPs. Cool. So that paper is, it's actually gotten accepted, it seems, for a journal. And
congratulations.
And it'll get published this year. And so the paper's almost to the complete, it's pretty much done. It's about 150 pages long, which is much longer than you expect a scientific paper to be. It's basically a book. But it's quite extensive, and it took a lot of work to put all that information together. So I'm really, and we have, how many authors? I think 33 authors or something like this from around the world. Yeah, so we've got, people who've been studying UFOs for decades are involved. We've got new people. We've got people from other countries, and in some ways, we needed to do that. I'm the lead author, and so I needed to do that because that's just a lot of work for one person.
Wow.
And we all know different things. And so we were putting everybody together. What can you write about this? What can you write about this? And, when I learned so much putting the paper together, it was really, really remarkable what's all been done so far scientifically to understand these objects. And so it'll be a great service to scientists to have this published, because the scientists, the general opinion was like, this has never been studied. It's not exactly true. It's been studied underground and on the down low, right? And
interesting. Oh, so does your survey include some invisible college work, like from groups who never went public with their research?
No, not really. Okay. But a lot of these groups just aren't well known. That's all. So so we've got some information about that. We went well into what other governments have done, and what's known with other governments and what activities there were. So we talk a great deal about the U.S. government's work, going back to Projects Grudge and Sign and Blue Book and all of that. And some of that's well known, but some of it's not well known. What isn't as well known was the difficulties that the U.S. government was having with UAPs, green fireballs, they called them. We didn't have drones then, so we didn't call them drones. We called them green fireballs. There were green fireballs in New Mexico near White Sands Missile Base and Los Alamos in the late 1940s, early 1950s.
Okay.
This was after Roswell, which was 47. So we already had nuclear weapons then, and so these were very sensitive areas. And in fact, these things were widely observed in New Mexico. And you can also get the general question, why don't astronomers ever see them? Well, astronomers did see them. And in fact, several astronomers were involved in this work on trying to study these green fireballs in New Mexico. Clyde Tombaugh, who discovered Pluto, saw 5 of them. And so didn't just see one, he saw 5 of them.
Through instruments or by his eyes? Visually.
Yeah.
Wow.
On several different occasions. In fact, they had meetings at Los Alamos on what they were. Lincoln LaPaz, who was a meteorite expert, headed those studies. And he was trying to chase down whether these were meteorites or not. They would fly past airplanes and he would get sighting information and construct trajectories and show that these weren't always going down. Sometimes they're going up. Sometimes it was level flight. And he was an expert of computing these trajectories and actually finding meteorites. And almost always he could find the meteorite once he had a trajectory. And with these green fireballs, he never found a meteorite. None of them. He made that point very clear in these meetings. And in fact, the meetings at Los Alamos involved a lot of the physicists at the time. And it was interesting because they didn't debate whether they were real or not, because most of the physicists at Los Alamos had seen them, which is not well known. And so, it's mostly believed that nobody ever sees these things. No scientists ever see them. Most of the scientists involved at Los Alamos, including Ed Teller, Teller, who worked on the H-bomb.
Hydrogen bomb,
He had seen them as well. And his take on it was that they were some kind of electrical effect because there was no sonic boom. They were moving at supersonic speeds, but no sonic boom. And this is what a physicist would come up with, because you expect something traveling at supersonic speeds to create a sonic boom.
Right,
In fact, Avi Loeb and Kirkpatrick from Arrow wrote a joint paper on the fact that these UFOs moving at supersonic speeds ought to be creating sonic booms. You would expect this. And the fact that they don't is the big problem. And in fact leads a lot of people, a lot of other scientists, including many of my colleagues, to believe that they're not craft, because a craft would have to create a sonic boom. The problem is that we have a lot of other additional information that they never create sonic booms. And these things have been really well observed in some cases.
And I've heard you describe that similar envelope situation applying to USOs, things underwater moving very fast, should be having effects that they're apparently not having.
And they don't. They don't at all. In fact, I know of a case in New Zealand where they had an object was following a ship. They beamed it with sonar. It was 150 feet wide and 800 feet long, which is 30% larger than the Typhoon class submarine.
This is the object that they're tracking.
This was the object underwater, and it closed. It closed a couple kilometers in about 25 seconds, and went under the ship. Took all the power out on the ship, drained the batteries, everything. They were actually adrift. Couldn't even radio for help. No power at all. No waves, no water disturbance. And the problem is, how do you just think of this? You've got something with a 150-foot girth has got to push a cylinder's worth of water, a 2-kilometer cylinder worth of water out of the way in 25 seconds. That water's got to go somewhere.
Right.
And
so
it didn't.
It's like sneaking through it somehow.
So what happened? This is the sonic boom question, but with water.
Right.
And
So
the other,
as a physicist, is that the weirdest thing that they do? I've been curious for you.
that
of
is
the
probably,
observable.
in my opinion, the weirdest. That and the extreme accelerations are the weirdest things that they do, physics-wise. Yeah.
Do you have a personal theory about what could account for the slippage?
Not a good one. I don't have a good one that can. What you want is you want a theory that can accommodate all of the data, and we don't really have a theory that can do that. And the data is confusing because we don't have an idea of what's going on. In fact, they recorded it with sonar. Actually, I have the sonar measurements from that case. They recorded it with sonar as it was accelerating and coming toward the ship at something like 3,000 miles an hour.
Wow.
And underwater, 3,000 miles an hour. And the question is, if it's acting as if it doesn't interact with the water, but
Right.
That's how sonar works. Sonar works by water molecules banging on the object and bouncing. You've got pressure waves underwater, right?
So it's at least interacting that much.
So it's interacting to some degree with the water, but it's not pushing the water out of the way. I mean, how do you put those two together? It's very, very difficult.
Wow, that's a classic double slit experiment, head scratcher.
It really is, yeah. So what we really need is we need more data, better data.
Is that sonar data on the public record? Sorry to hop in, but is that
no, not yet. Not yet.
Okay.
Eventually, I will put together, once this big UAP paper is done. It'll be out of the way in January. I've got to get it back to the editor by January 12th. So,
okay.
Once that's done, then I will be working on the paper at some point I'll put together this year. I'm planning on putting together a paper having to do with the underwater case that I have.
Okay, so let's click back out to the level of papers. This new historical review is the latest thing you've been working on. And then I have two others that are on my radar, so to speak, from you. One is estimating the flight characteristics of unidentified aerial vehicles, which is amazing. It's a rock star.
That one's been published. I would really like to update that with more data and more information, because there's a few more cases that we now have that are radar cases that have been looked at. One of them was written up by Claude Power, the French researcher, on the Minot Air Force Base encounter that happened in 1968. So that's an Air Force base in North Dakota. But there's actually radar data on that case as well.
Oh, cool. I'm not familiar with Mr. Power's work. Claude Power, French engineer?
That's right. Yep. So
Great.
He has a nice paper on the Minot Air Force Base encounter, and that. So I'd like to incorporate that into the estimating flight characteristics paper. We also when I wrote that paper, I didn't go into detail with the radar data that we have on the JAL 1628 case. I just basically summarized I summarized the situation analysis and basically did a back of the envelope calculation on how fast it would have been moving.
Okay, the JAL, just to remind folks, and myself, is the Japan Airlines cargo flight incident in which the pilot reports seeing an object so large that it filled the windscreen of their windshield of their jet.
Yes.
An extremely large, extremely fast object, and it moved with them for quite a long time.
45 minutes.
Wow.
45 minutes it followed them. Yeah.
And there's radar data on this object?
There's radar data on that. The Reagan administration sent their scientific advisory board along with the CIA and FBI to meet with Callahan was the head of the FAA Accidents and Investigations division, and they met with him and basically took the radar data. And according to Callahan, they were excited because this was the longest period that any UFO had been observed with radar. Now Callahan was smart. He knew that they were probably going to take the data, so he duplicated it.
Nice.
He kept it in a box under his desk. Hide in plain sight, right? Hide in plain sight. He kept it in a box under his desk for years until he retired, and then he released it publicly.
Wow, good man, Callahan.
Yeah, that was a smart move, and that's incredibly beneficial. And so the so that was that was analyzed by the physicist from the Niels Bohr Institute. He wrote a book called Anomalous, and he analyzed it in that book and found that the object was making jumps from basically, I mentioned this in our paper, basically going from, 1 o'clock to 6 o'clock, making jumps around. It wasn't just stationary around the airplane, it was jumping around it, keeping a distance of something like 8 kilometers.
Okay.
But every 12 seconds, in a 12-second sweep of the radar, it would be on one side and then on the other in the next sweep of the radar. So you can get an idea of how fast it had to have been jumping that way. And so I just kind of took an average of that and looked at it and found that it was, clearly accelerating at high rates. But when you look at that in some detail, Daniel found that it's in some cases accelerating at 10,000 Gs. 10,000 Gs with the top speed would have had to have been 250,000 miles an hour.
Oh my God. And so, I've heard you describe this.
Some idea of how fast 250,000 miles an hour is.
Yeah.
That would get you to the moon in less than an hour, about 50 minutes to the moon.
And it's vastly, vastly higher than any acceleration that we have created so far in any equipment.
Vastly higher than anything we can create. 1,000 times higher than anything we're used to.
You've said before the F-13s or F-35s would get their wings ripped off at what, like 10, 13 Gs?
About 13 and a half Gs. Yeah, the wings will get ripped off. Yeah.
And is the fastest human-made object still the NASA's X-47? Is that right? It was like a jet.
For plane, I don't know there's a lot more information now, and now we're doing hypersonic work. So it's not clear what our fastest planes are at this point. Our fastest space probes are, on the order of 35,000 miles an hour.
Okay.
The New Horizons probe that went to Pluto is 35,000 miles an hour.
Okay, but it took years and years to get up to that speed.
Yeah, we use gravitational assists and all this sort of thing to get it up to that speed. Yeah. And all the histrionics getting it off the planet in this giant rocket, right? I mean, but this craft, the JAL 1628 craft was 3 times the size of a 747. The pilot estimated it to be. So it's the size of an aircraft carrier. So this aircraft carrier-sized object's accelerating at 10,000 Gs, top speed 250,000 miles an hour. It could get you to. It could get us there. It could get you and me to the moon by 12:30. It's 11:30 a.m. now. We could get to the moon by 12:30, have lunch, and be back by 2.
And so
that could do. That's amazing.
It is.
And I want to understand these objects. I don't want to waste time arguing over whether they're real or not. If a pilot sees something that fills the air screen and we have radar data that shows it moving at these speeds, that's interesting. Let's study this.
I totally agree. It's a red herring to discuss the reality at that point. And actually, that pilot
waste of time at this point. Yeah.
I think that pilot was benched for several years. Maybe ultimately fired. I don't know how that was.
Well, he was fired. He was fired, and then finally had his job reinstated. But it took years. Yeah,
that's good. Well, I just want to say, while we're in this area, thank you so much for the rock star leadership in this particular area, taking this approach, leaving the unanswered questions to the side. What can we conclude from what we know and what we're observing? And I think that's a really brilliant avenue of inquiry. And I think people should check out estimating the flight characteristics of unexplained aerial vehicles or unidentified aerial vehicles. Also, I appreciate that you called them vehicles. I think there's an act of politics even in your titling work there. I got some pushback from the reviewers on that, but I actually didn't budge. I was like, tell me they're not vehicles. Tell me what they are instead of that. Right. So I guess let's click on that question. Atmospheric phenomena Does that seem completely crazy to you as an explanation at this point?
Crazy, because it's completely crazy for a simple reason. These things are not poorly observed. These things are well observed and well described. The Tic Tacs in the Nimitz encounter were described as being Tic Tac shaped objects, white, seamless. They didn't see riveting and segments. They also had these little protrusions, like these little feet at the bottom that stuck out from the bottom. They saw it with that kind of detail, right? You see something with that kind of detail, you have to ask the question, what do you want from somebody when you're asking them to identify something? Do you want to give you a make and model number? Do you want them to, or do you just want a description? Because if you want a description, we have very good descriptions of some of these objects. These objects are well described in some cases. And in fact, the Tic Tac case, it's very well described. It's so well described that if we saw another one or we got a picture, we could say that's probably the same craft. I mean, that's the level of description you're looking for. And so do we know what it is? No, we don't know what its origin is, but we can identify one at this point. And that's what you mean by identification. So they're not unidentified anymore in that case. The term unidentified is this vague term that can easily get thrown around loosely to just, well, it's unidentified, so it could be anything. Well, that's not real at all. That's not reasonable.
Right. It seems like there are basically three buckets. There's atmospheric, there's human, and there's non-human technology. And I think you make a perfectly clear point there that atmospheric is a very low percentage idea. And it gets...
And there are some objects which still could be atmospheric, which are interesting. A lot of the orbs that are seen very well could be atmospheric effects. The lights, the Hestelin lights in Norway could be atmospheric.
Okay.
Do they sometimes act as if they're under intelligent control? Yes. So that's confusing and interesting.
The Hestelin lights.
Lights seen here in New York, in Pine Bush, New York, south of here, south of Albany, about an hour drive. Similar lights are seen there.
Okay.
So could they be atmospheric? Yes. Could they be plasma? Yes. Do they act like they're intelligently controlled? Sometimes. And so, how do you determine whether something's intelligently controlled? What tests do you need to do? What experiments do you need to do? What types of data do you need to collect? Those are questions that I would ask as a physicist, and I can't say for sure that they're intelligently controlled, but that's a question that's now raised that you can study.
It is a really good question. And the answer comes back over 100,000 reports over many years of people saying, I don't know, but it seemed like they were. How do you approach that?
Exactly. So how do you deal with that? Right.
How would you set a parameter to say if it was doing X, then we would presume reasonably that it might be intelligently controlled?
Yeah, well, that's hard. I mean, if you tried to interact with it in some way and it interacted with you, then perhaps you might classify that as intelligently controlled. That's not exactly right, because you could, when you take a candle flame, if you put your hand by it, you can make the candle flame move. So you can't necessarily assign causality to correlation. That's what it really comes down to.
I see.
And so it would require multiple experiments, trying many different things. If you had multiple orbs at the same time and they moved in some kind of synchrony, that would suggest intelligent control. That's what you see with UFOs, with the flying saucers and other craft. And that's what happened with the Tic Tac, that, when Fravor descended to go check out the Tic Tac, the thing came up to meet him and then circled, along with him. So it's interacting with him, and it's a big object, not like a candle flame. So there you can, I think, pretty reasonably assume that that's intelligent control. That's what you mean by intelligent control.
That seems likely too. And to me as well. And it also sort of feels like this is as interesting as it is, maybe not the question that we need to answer most pressingly. I praised you for doing this, and then I immediately left this subject. But the questions that it seems like you've been pursuing are: what are they doing, and how could they possibly be doing this? Does that seem right? At least in the estimating flight characteristics.
Yeah. Well, as a physicist, I'm aiming to tackle the things I know how to tackle.
Mm-hmm.
So those are questions I can attempt to answer best. So that's where I can do my best work. Is that what interests me the most? Maybe not always, but that's what I can work on, and those are questions I can figure out how to answer.
So moving extremely fast, accelerating extremely quickly, these are things that they're doing and not affecting, for some reason, the air or water.
The medium
around
that they're
them.
in, air, water, whatever, yeah.
And not off-putting massive amounts of energy from their braking. For example, I've heard you talk about the Tic Tac-like objects that were descending from 80,000 to 20,000 feet and then stopping without releasing an explosion somehow. And we don't know.
Yeah, where did that energy go? Yeah, where does the energy go? And how and if they are craft, then how are they dealing with these amounts of energies? I mean, the amount, so that instance that you're describing was in the Nimitz encounter, the Tic Tacs that were detected on radar by Senior Chief Kevin Day on the USS Princeton. He was seeing them drop from about 22,000 feet to sea level in 0.78 seconds. That's a pretty accurate measurement, 0.78 seconds.
Yeah.
How wrong is he going to be? Well, maybe he's off by a second, but he's not off by 10 seconds. So these things are moving fast. I mean, they're moving incredibly fast. You can put bounds on that and still show that these things are moving at thousands of G's of acceleration and hypersonic speeds. So then the question is, how much energy, how much power did that take to perform that transition? And if the Tic Tacs are about the size of an F-18, you could assume that they're the same mass of an F-18, but we in our paper went with 1/10 of that. Went down an order of magnitude. Let's say they're the same size of an F-18. Let's drop the mass by a factor of 10 to try to get a bound on how much energy we expect. And you come up with numbers which are thousands of gigawatts of power. I mean, and it's insane. It's
more than the nuclear output of the United States.
More than the nuclear output of the United States, yeah.
For any one of these maneuvers.
For any one maneuver, yeah, it's crazy. The amount of energy involved would be crazy. And so then the question is, what happened to that energy when it stopped? Because the energy has to go somewhere. So that kinetic energy went to something.
Yeah. Did they put it in a battery? Maybe
they have a flywheel.
They've got a
car and the flywheel spins up. I can't imagine how you could do something like that with any kind of instrument.
Would it have to be something like that? Would it have to be like an internal energy sink where they absorbed it and put it into some kind of?
It could be. It could be. It either went internally or externally, and we have no evidence of it going externally.
If they distributed it, we didn't notice.
We didn't notice, and you would have noticed because you can then take that amount of energy and figure out how much you'd have to dissipate. And so we estimated that would have to be it would be equivalent to 250 Tomahawk cruise missiles going off at once.
Oh my God. So do you think
should have happened when it stopped? It should have just blown a hole in the water.
Yeah.
Right?
So,
but that doesn't happen.
Does that leave you concluding that there's some kind of regenerative braking going on, like some very advanced version of containing that energy?
I have no idea what's going on, and this is why we have to collect data. You could, it would be nice to assume that they can just reabsorb that energy and use it again. That's not how thermodynamics works. So, I don't have a good theory of what's happening, and these are the questions that a physicist ought to be asking.
Yeah.
And
convenient that you are one.
And then the question is, what happens when? But how do you engineer something like this? So they're dealing with thousands of gigawatts of power. No system is 100% efficient. So let's say you've got a 1% inefficiency. So this thing is, most of the things we make are, our heat engines are 20% efficient or something like this. So that's an 80% inefficiency, right? So let's say they're really good at what they do, and you've got a 99% efficiency. So that means 1% of the energy they're dealing with is going off into waste heat, right? Mm-hmm. So 1% of 1,000 gigawatts is something like 10 gigawatts. So it means
still look like an explosion.
So or 10 gigawatts of power has to be being dissipated as heat energy, as waste, right? But that would melt the ship. If it was an F-18, it would melt the ship in seconds.
Yeah.
So even there, the engineering wouldn't work in our minds, right? We can't even figure out how you could engineer something to deal with those amounts of energy. So what does this do? Some physicists will hear this, and I know this from experience because many of my colleagues will say this, well, that's impossible. The whole thing has to be wrong. The whole thing has to be wrong.
The data must be incorrect.
The data has to be incorrect. The whole thing has to be wrong. Well, we have enough information now to know that the whole thing can't be wrong. Mm-hmm. So something is wrong in our thinking. We're thinking about the problem wrong.
Yeah.
Maybe they're not accelerating and moving the usual way that we imagine them to be. Mm-hmm. Maybe they're not dealing with those types of energies. They're doing something else. And is that a possibility? And it is. What other things could they be doing? Well, they might not be moving from point to point as they drop. What if they, here's just a hypothetical. Mm-hmm. I don't have a theory for this. There's no physics for this. What if you teleported 3 inches each time? Teleport. Mm. It would look like you're moving fast, but you're not actually moving.
Because you're hopping, so you're not pressing through the air.
You're not just pressing through the air. Yeah. So you would be hopping. You're not accelerating. You're not moving, so you're not accelerating. So it deals with the acceleration problem. That would deal with the interacting with the medium problem. It would deal with the energy problem. But it's a totally different solution, right? And it's a solution we don't have a theory for, but but that could very well be what we're dealing with. So you're then faced with, you've got really 3 choices. You've got either all the data has to be wrong, belief. You've got the we just haven't figured out how to do something like this yet. Mm-hmm. With the physics we know. So you stick with the physics and then try to get it to work somehow engineering-wise. Mm-hmm. Or you assume, say, clearly there's physics we don't know, and we have to do something new with physics. And that one's really a last resort. You really don't want to assume new physics until you really have enough evidence to show that there's a reason for that.
Right. Okay. So that's either really.
So I'm kind of in the last two. I'm not willing to throw out the data because I've seen too much data.
Yeah.
These things are interesting. Let's figure them out. Let's work through this. But it means that we have to either figure out the engineering, or you have to figure out what new physics you need. And I really would prefer the former than the latter.
The engineering solution.
The engineering, yeah. The engineering, that really should be your first step. And then the new physics would be a second step.
So ideally, it's some kind of highly efficient energy system that outputs amazing amounts of energy, but also then somehow finds a way to retain it. So
hide it. Somewhere. I don't know where.
But if not that, then it's some form of teleportation hopping or
something else.
Maybe something
we
weird
don't at all know what's going on.
I think it's fascinating that's all.
Maybe something with time. Well, that's an interesting suggestion too. Maybe you're playing with time to some degree, right?
Yeah. Like they're moving through the 5th dimension or something, like they're moving at a speed that would be regular to us now, but they're moving through time in a different weird way that would allow our physics as we understand them to continue to operate.
Yeah, and at this point, we're just making up ideas at this point. But but that's fine to do. I mean, it's fine to do, and then come up with something that's testable and test it.
Yeah. I mean, we're in scientific revolution territory, right? So it's time for a new paradigm in some way. And I think it's fascinating and cool that this is all to the side of whether they're extraterrestrials or like techno angels.
Oh, yeah, we haven't even dealt with where they're from or who they are and what's going on here. Yeah.
There's just this fascinating field of physics to explain and explore. And I think it's great. Again, sorry to repeat myself, but I think it's wonderful that you're leading the charge in that direction, because a lot of the field seems to be stuck at level one of, well, is this data even accurate? And they're not getting to the really interesting stuff. But I think you're going to inspire people to get to this more interesting stuff and come up with some really cool theories. But just because we mentioned it, and I'm at risk of repeating myself now or taking us around in a circle, let's go to the origin stuff, because another major paper that you've written about this is simulating the characteristics of extraterrestrial civilizations that encounter Earth. Is that your most recent published paper? I saw it was 2024. Is that right?
Yeah, that was from the spring. Yeah, that's the most recent one.
Cool. Would you like to talk about that a little bit?
Yeah, I wanted to answer for myself. I wanted to answer the question: is interstellar travel possible? Can you pull it off, right? And so I thought, well, let's simulate it. Let's just simulate millions of civilizations that are doing this, and to see if you can actually find Earth or colonize star systems and actually do this. And yeah, the answer is yes, you can. It is possible. It is possible to do it with, and really, I considered only up to relativistic speeds, up to the speed of light. I did not consider faster than light travel, and a lot of my colleagues and friends have kind of criticized me for this. Well, why didn't you consider hyperspace and all this? Well, and the whole point was, well, let's use the physics we know about. Let's use the physics we know about first. And figure out what we can do with that. And then you can try that other stuff later.
And to this point, you were even conservative relative to the accelerations that you've measured in estimating the flight characteristics.
I limited it at that. I didn't go, I think I limited the simulations to 10,000 Gs or something like that, no faster than that. And then I did many simulations. I just chose those accelerations randomly, the maximum speeds randomly in this, and then see what they could do. And found that indeed you could have craft that are interstellar capable, accelerating at, reasonable accelerations, 1G, 2G even, getting up to speeds at 20% the speed of light, which we think we can probably pull off, and can actually find Earth. It can work. It's not common. You'd have to have lots of civilizations nearby to be able to get here, but you could pull it off. Yeah.
I saw, to your point about not common, your conclusion was that maybe there was a small overall probability of 0.000009% that a spacefaring civilization would visit Earth in those parameters. Is that around right?
Yeah, there's something. I don't remember the numbers off the top of my head because I've been buried in my other paper. But
okay, but small probability given that.
Yeah, the chance that I'm just going to open it because
oh great,
I'm going to say something that I didn't say in my paper and get numbers wrong. But yeah, the chance of finding Earth is very slim because the galaxy is huge. There's 400 billion stars. So the possibility of finding Earth in the first place is going to be difficult. But
if you limit it to 10,000 Gs or lower.
Yeah, or even if you could travel faster than light, finding Earth is still going to be hard because there's too many places to look, too many places to go. Yeah, so when I did this, I found that only about 22% of spacefaring civilizations were capable of interstellar travel. It's only 1 out of 5 of them who can get into space can go to other stars. So that to me seemed reasonable. Yeah, the probability of finding Earth was 0.000040 zeros and then 9%. So about 3 zeros and 10% that you could encounter Earth.
Assuming those parameters of
yeah, exactly. So what was interesting though is to be able to get that estimate because If you then have some additional data which tells you that somebody has found Earth and has visited Earth, you can then estimate how many civilizations there ought to be in the galaxy.
Yes.
And so so it kind of ends up being like a Drake equation, but with evidence. So you get a little bit of evidence about that somebody has found Earth. That tells you that there are about 1 million spacefaring civilizations in the galaxy. And
of which about a quarter
of them are interstellar capable, right? So you would have 250. So if somebody has found Earth and is traveling using relativistic travel, not faster than light, then you can estimate that there have to at least be 250 million, quarter of a million interstellar capable civilizations in the galaxy. This is bigger than Star Trek. That would be bigger than Star Trek.
Yeah, there are
more
only like
civilizations
4
than you expect from Star Trek. Even
So
it would be a pretty crazy galaxy out there.
And you further conclude doing that kind of backward work. If somebody did find Earth, then you calculate the median or the mean time during which they might have done that, right? And you found a range between 4 million years almost ago, like 3.44 million years ago, to as recent as like 100,000 years, something like that. And I think you said the mean is about 1.17.
Yeah, it's 1.17 million years. So you can estimate how, if you find someone on Earth today, you can estimate on average when they would have had to have first discovered Earth or first arrived at Earth. That would be about 1 million years ago.
Yeah.
So you can now, just doing simulations like this using reasonable physics, and the engineering isn't totally reasonable because we don't know how to go barreling through the galaxy at 80% the speed of light. You're going to run into all sorts of problems at those speeds, at 80% the speed of light in the galaxy. First, the problem is you have one thing that benefits you is with relativity is time dilation. You're moving fast relative to the galaxy. Your time is moving slower than the galaxy's time. So you can travel
a week
greater distances in smaller periods of time for the traveler, right? It'll still take 80,000 years to get across the galaxy, but for you, it can take 3 months. It'll be a 3-month trip for you, 80,000 years for the galaxy. So there's no... You aren't going to make it. Can't go somewhere and then come home in time for dinner, right?
I heard you use the phrase, or saw you use the phrase "proper time" in estimating the flight characteristics. Is that by that you mean proper as in like local to the traveler time?
Yeah,
I think that's how I understood that.
Yeah, proper time is it's a relativistic term for keeping track of. It keeps track of the lengths of space-time intervals.
Okay.
So what's happening when you're traveling at relativistic speeds is you are lengths are contract. So there's two perspectives. So if you're traveling at relativistic speeds across the galaxy, from the galaxy's point of view, the travelers, the clocks on the spaceship are moving very slowly. So
and that's proper time in the spaceship.
That's the proper time in the spaceship, right?
So what do you call the galactic time? Universal time?
Well, it's proper time for that in that frame of reference. So in the frame of reference for the galaxy, it's going to take thousands of years for them to get from point A to point B.
So proper time to the Enterprise.
So it's proper time is the time for in that frame. Yeah.
Okay.
So the other perspective is that the other thing that happens is that lengths contract. So as a ship flies past you at close to the speed of light, it looks very squished. But that's the perspective that the travelers have. The travelers have the perspective that instead of this big galaxy you're traveling across, when you get going very fast, the galaxy squishes into an ellipsoid, very narrow ellipsoid, and you're just making a small trip, a small distance from one side of the galaxy to the other.
Oh man, you're reminding me of the physics problem that, as I was taught, you're running through the barn with a ladder.
Running through the barn with a ladder. It's the same problem. Yeah, it's the problem of running through the barn with the ladder. So if you run through it close to the speed of light, the ladder is fairly squished, and yes, there is a time when the whole ladder is inside the barn. But
even though the ladder is
they-
longer than the barn.
The ladder is longer than the barn in the frame of reference of the ladder. Yeah.
Oh, very heady stuff.
Yeah, that's exactly what's happening here. And so you can now see the problem of interstellar travel gets translated to this. And then, so traveling at 80% the speed of light is you are basically taking all that space between you and your destination and squishing it. And space is not empty. You've got about, something like a hydrogen atom per cubic meter or something like this. And so now you're going to squish this space and you're basically creating a hydrogen cloud. And so now you're flying through, not very far, but you're flying through a hydrogen cloud at close to the speed of light.
Which makes the mass of these hydrogen molecules pretty significant, right?
It's pretty horrible. Yeah, it becomes horrible. And this is where it would be beneficial if you can travel through a medium without affecting it.
Yes, having that slipstream that they're creating underwater.
If you can travel through the air without a sonic boom, then maybe you can travel through a hydrogen cloud at 80% the speed of light and not be affected by that either. And so now you can start to piece together, well, maybe this is what's going on here. Maybe the reason there's the fact that they can travel interstellar travel at relativistic speeds perhaps allows them to also travel through the air at 10,000 miles an hour without any sonic boom.
Yeah, whatever the trick
related
is.
to each other.
It works for both situations.
That engineering would work for both solutions, would solve both problems, yeah.
If you widen the parameters of how fast these craft could accelerate, would you conclude that there would be more civilizations or fewer? Like if you took that parameter up and said like they can travel. Well, let's go there. Let's say like if you introduced faster than light travel to this scenario, how would that affect the number of civilizations that you would calculate? Would it tend to increase our guess about how many spacefaring?
It would decrease it actually. Because it would make it more probable to find Earth, which means that there would then if you had evidence that somebody found Earth, then there could be fewer out there.
And would it likewise shrink the guesstimate of how long ago they might have arrived here?
How would it change that? That's a good question. Yes, it would decrease that as well, because that estimate is basically coming from the length of time that it takes a civilization from starting out to colonize to a point where it finds Earth. And if that can be done faster, then they don't have to have been here that long. Yeah.
Okay. So while we're in this ballpark, what are your armchair intuitions about faster than light drives? I heard you cite Alcubierre, Davis, and Bobrick and Martyr as people who have researched faster than light, but you're mentioning that to say we're not going there.
Others have done this too. Others have worked out space-time metrics for warp bubbles and things like this. This is now more something that people are looking into. In fact, another UFO person you probably know of is Travis Taylor. Travis Taylor has also written papers on warp drive bubbles. So I was able to see one of his papers in the early stages at one point. And so yeah. So is that possible? Yes, it's possible. Is that what's going on? We don't yet know. There you'd have to look at see what effects a warp bubble would have on an atmosphere here on Earth, so that you could, when you saw a UFO that was using a warp bubble to travel, you could actually detect it. What you would expect, just back of the envelope calculations, so this is just some quick number crunching, is that you're going to have some kind of anti-gravity below, right, to keep the thing aloft, and gravity above to pull it up. So you'd have blue shifting of light below, and you should have red shifting above.
Interesting.
And so objects should appear blue shifted from below, which means you would see them as hotter. Right? When you looked at it with an infrared camera, it would be hotter, but that's not what we usually see. We usually see that these things are colder.
Interesting.
And so, And so,
like within our atmosphere, you're talking about like
then the FLIR image, most of the FLIR imagery shows cold objects. Go Fast is a good example. Go Fast is it's an unfortunately named video because the general thinking is that it's supposed to be going fast because it's called Go Fast. I don't know how people mix these things up. Nobody said how fast it was going. In fact, if you do the calculations, a lot of it's parallax, and it probably isn't going very fast, right? It's called Go Fast because it looks like it's going fast because of parallax. It doesn't make the video ridiculous at all. It just makes this idea that it's going fast ridiculous. It's not going fast. What's interesting about it is it's looks like a spherical object. Not obvious how it's staying aloft. There's no obvious means of propulsion that you see from the FLIR imagery. You don't have any jet exhaust. So you don't have any evidence of that. And it's cold. The object is cold. It's colder than the sea surface. So typical objects that humans make are not cold. They are usually hot.
I spoke with Rich Hoffman about the rubber duck UFO video also, which is another quite cold object.
It's a cold object, anyway. Right. And David Mason, who we worked with at UAPX in Catalina, he had an image that he took in Seattle of a trefoil-shaped object following an airplane that was coming in for a landing. And that was cold. That was about 65 degrees below zero, negative 65 Fahrenheit, something like that.
Okay, so you're saying the coldness contradicts what we would expect if we were looking at something going fast.
And that was a cold image looking from below. Yeah, so if it's using anti-gravity, you've got blue shifting. It should not be cold. It should be hot.
Cold. That's interesting.
Yeah.
Okay, well that's something anyway, something to go on.
It's a little contradictory again. I mean, this is what we keep running into. The data seems to be contradictory to a lot of our theories. So our theories aren't right. So there's something for us to learn here. That's the way I like to look at it.
Yeah, and potentially a couple of really interesting things: the physics, the engineering, and then whether we're alone in the universe, multiple civilizations, et cetera. But just staying on the FTL just a little bit, because I'm a layperson, I'm curious: does it affect our understanding of time if FTL is possible? If objects can travel faster than the speed of light, does that imply that some versions of time travel are real?
Well, that's not. It depends on what theory you'd need to describe what they're doing.
Okay.
You need to use to describe what they're doing. If they're using a warp bubble like the ones I referenced in the paper, then that's completely describable by general relativity. So we would already understand that.
Whew. That's a relief.
But if they're not, but from the data that I've seen, that doesn't support the warp bubble idea. So Are they doing something else? They could still be something else. So yeah.
So I've heard people make this claim that if you could go faster than the speed of light, then you would essentially be going back in time, or you'd be moving through time in a different way than we currently understand time to work.
Yeah, moving through space is related to moving through time. They're related to each other. So yeah, these things are inextricably linked, and we'd have to, whatever theory you have for moving through space, it's going to affect moving through time. So you then have to look closely at that.
I will be honest, it's not my favorite hypothesis, but I'm curious what you think from an armchair perspective of the extraterrestrial hypothesis that just some of these craft are moving through time.
It was not my favorite originally. At this point, we have to keep all the hypotheses on the table until we have evidence to rule them out. And we don't have any evidence to rule that out yet. So, yeah. So could they be time travelers? They could very well be time travelers. It's usually assumed that they're time travelers from the future. They could be time travelers from the past. It could be from the distant past. You had another race here that was intelligent and had space travel and time travel, and they could have traveled to the future to see us.
Or they could have gone far across the galaxy and then returned, and with their own proper time.
Something like that too, yeah.
Wouldn't have been too long. So picking apart some of the avenues of inquiry here going forward, there's this the loopiest, farthest out, and as you said, sort of last resort is different physics, as in teleportation or time hopping or warp bubbles or something like that. Then there's just imagining how the engineering could work with the physics as we currently understand it, given this radar data about rapid motion of large objects and apparent lack of dissipation of energy. Then there's this area of inquiry around civilizations. What does this imply about numbers of civilizations, about how long they might have been here? And then there's more social stuff, like how do we get people to pay attention to these things? But those seem like the three scientific avenues. And I kind of want to ask you about the potential limits. Like, what are the outer limits of the taxonomy project? Like the descriptions of these things. Can you see a time coming where we've described them as well as we can without some kind of like direct interface with the intelligence operating these machines? And sort of somewhere on the spectrum of that question, I think I heard you mention the idea of luring some of these UFOs into a potential experimental environment, say, where we could get better data about them. Would you like to speak to that at all?
Yeah. So, well, first, like the taxonomy, at first we're going to just be able to describe shapes of these craft and maybe, if we're lucky, flight characteristics. I'm often asked, so how do UFOs fly? Well, the problem is you can't ask a general question like this because they could be using different technologies. This could be part of the answer. I was noting a few minutes ago about how these things often look cold, and that goes against this space-time warp bubble idea. But you could have UFOs that are using space-time warp bubbles that we don't have infrared images of, and the ones that we do have infrared images of aren't using space-time bubbles, they're doing something else. So you could have different technologies at play. Just like, you can't answer how a car works. Is it a gasoline engine? Is it a diesel engine? Is it an electric engine? Is it a hybrid? There are many different types of cars out there. So you can't ask that general question until you know the taxonomy. So we have some taxonomy work to do.
And we have some evidence that some of these pieces of tech might be different. I was talking to Rich Hoffman, he talked about a surprising finding that triangles that were not associated with electromagnetic effects, for example, in some of their surveys of historical data.
Yeah, some UFOs have electromagnetic effects. Some don't have obvious electromagnetic effects. So one commonality that I noticed and haven't worked the statistics out on yet, and I don't know if I will. There's just lots of things to do, but very often when there is a landing and a takeoff, these things will often take off the ground to something like 30 feet and hover for a second and then shoot off at incredible speeds, right?
Yeah.
They never go from the ground. I don't know of any reports going from the ground just to incredible speeds. Huh. They always go up some distance, hover for a second, and then go.
That's reminding me of how Superman usually operates. He floats a little bit.
Push your arms forward further and you go faster.
Right.
That too. But I know what you mean, yeah. And then, so they seem to do that. They seem to have that in common. Now, that's just my, I could be biased from the cases I've looked at, which is why I haven't worked all this out. But then the one thing I did notice is that they seem to use different techniques to get off the ground to start. Mm. So in the Socorro, New Mexico case with Lonnie Zamora, the ellipsoidal egg-shaped UFO basically looked like it had rocket engines.
Yeah, like a blue flame.
Rocket engines, which had flames and actually scorched the ground and bushes, and lifted up with that, and then hovered and then took off really fast.
Switched modes, maybe.
So like it switched modes. And then there's a case in France where it was in a field with grass, and it was a disc, and then lifted. I think it was a disc lifted up, and then this had electromagnetic effects. The grass all pointed like it was electrified and pointed at the craft,
Wow.
lifted off this way and then hovered for a second, then took off. And so that one looked like it might have used some type of electromagnetic means, some kind of, way of lifting up that creates electromagnetic fields. So, so they could be using different techniques to make different maneuvers.
Yeah,
you can have different types of engines involved in different cases. Yeah.
Yeah, just for casual description of this, it occurred to me that Neo from The Matrix does the other thing where he blasts off to a top speed right from the ground.
Right from the ground.
Yeah, that's right,
he does. Yeah, that's right.
So for classroom description, Neo versus Superman, I don't know, maybe that's useful. So I'm interested in what interests you in this like next couple of years. Like what questions are you most eager to answer, or like what avenues are you most eager to explore?
I'd like to get better data where we have better imagery and better and data across the board. I would like to get more electromagnetic data, electric fields, magnetic fields. I'd like to get more measurements on radiation. I'd like to get spectra. So I think just getting data, in many different forms, sounds, what everything we can collect, just to start to try to sort things out. I think that would be helpful.
That is great. So we spoke actually to John and Jerry Tedesco. I know you know those guys, and you guys have worked together a little bit on some. I went
down and hung out with them for 2 days. Yeah.
Nice.
Great time.
Super cool. Big fans. We are big fans around here. So it sounds like this is kind of like the core area of interest for UAPX, right? And also maybe for IFEX, or is IFEX more academic?
IFEX says they are also interested in collecting data. They've been focused on satellites. They've been focused. They've had projects having to do with satellites. They've also worked on a project to collect data on UAPs from Mars, which was an interesting idea, to actually put measurements on a Mars rover and put them on Mars. I haven't spoken to Khan about that project, though. I'd like to learn more about that and what the motivation was for that.
That's interesting. Looking at UAP on Mars, or looking at UAP around Earth from Mars?
On Mars. Actually doing it on Mars.
Okay, so UAPX and Galileo.
So I'm not sure what his motivations were for that idea, for that project. I think it's a cool idea.
Yeah.
But I'm interested in learning more about the motivations there, and
I will hunt him down and ask him.
I will have to do the same. Maybe that's what I will do for my focus on that for my break.
Yeah, that sounds like a good recreation project. So UAPX and Galileo and Tedesco brothers and maybe a couple other operations are working on this sensor thing. I'd love to hear from you as somebody in the maelstrom. How's it going? How's it going with funding of sensors? And
funding is horrible. Funding's horrible for everybody. There's no money at all. It's coming from private sources, which we at UAPX don't have a lot of access to. I think Galileo's done best with funding. They have the Harvard name behind them, which is helpful, I'm sure.
But even Harvard is not funding them. At least the Tedesco brothers' impression of the Galileo funding was
it's not great there either. No.
Yeah.
And it's unfortunate because you've got this, NASA now has this mandate to try to study these things and has recommended to study them. But for that to happen, and you have to have funding. Even NASA would have to get funding to do it.
Right.
And at NASA, you can't just start a project that has no funding. So they would, and to do that, there has to be a funding opportunity available. So those haven't been put together yet. I would hope that happens sometime soon. I did hear Beatrix Villarreal, who leads the Vasco project in Sweden. She has gotten funding from the Swedish government. So bravo to her. That's a first, actually, for somebody to be federally funded
by the
UAPs, which is great.
I did want to ask you about that, but first I just want to say, I heard you say elsewhere, you gave a quote for your ideal sensor array, and it was not that high. It was on the order of a few $1,000s. Is that right? $15,000, something like that per array?
For the actual sensor array, yeah. Something like $15,000 for a sensor array. I mean, to make it, we need probably about $250K or something like that.
Each one, or
just for the manpower to put it together and to do the testing and get the instrumentation.
Okay, so that's overhead, and then you might be able to produce one array.
But the cost of one ideal one was probably around $10K to $15K. Yeah.
Okay, cool. So yeah, you're looking at the ballpark of like somewhere getting toward $1 million to have like a real widespread project. And how many of these arrays?
A solid project, yeah. For a solid project, you need about $1 million to really to do it. We could probably do an all right job, taking several years, at $300K or something like that. But you really wouldn't do better than that.
I guess that gets close to another thing I want to ask you, which is, how do you feel as somebody who's interested in this subject when you see literal billions of dollars getting spent on other far out scientific concepts like superstrings, or, well, the Higgs boson turned out to be real, but we spent maybe $3 or $4 billion trying to find it. I don't know how much we spent looking for gravitational waves, but a large amount of money. So part of my question,
it was also successful too. So
right. So it seems like the extraterrestrial hypothesis, or a non-human intelligence hypothesis, should be a pretty compelling reason to spend a few $1 billion. And certainly a few $1 million is like walking around money for some people who are interested in this subject, like Yuri Milner and maybe Robert Bigelow. And it would be, great to get some other silicon luminaries on this. But why is it so difficult? Do you think it's because the federal government is kind of blocking investment in this area? And
I think there's still a taboo and a stigma associated with it. I don't think I wouldn't say that there's an actual blocking or anything like that. I mean, you would need to have for the federal government to create funding, you need to have it go through a funding agency. So it would have to go through the NSF. It could go National Science Foundation. It could go through the DOE, Department of Energy. It could go through NASA. There's several different ways you could do that, but then that requires lawmakers to decide on money being spent on this in this area, and the lawmakers have to do it. Yeah,
I see. So it would need to come from Congress, at least, to be a public project.
It would have to come from Congress. Yeah.
What do you think about this more general question of getting social buy-in? And I guess this could be sort of upstream of Congress. If we get social buy-in for the idea that the extraterrestrial hypothesis or a non-human hypothesis is a reasonable thing to investigate, then maybe that can trickle down through Congress, which can turn into research.
Oh, that'll make a big difference. Yeah. Once people think that this is worth looking into, then you would expect that there would be funding made available, sometime later. I think that's one of the difficulties, is that it's still not the extraterrestrial hypothesis or the non-human hypothesis is still not really considered viable by many people.
So this gets to that.
Despite the fact that if you did have non-humans operating here on Earth, you would really want to know about that.
Yeah, you would. This is the part that has driven me the battiest thinking about this subject, is the logic that it's reasonable and highly probable. It seems pretty airtight to me. We've been seeing tic-tac-like things for 80 years. They're very likely not atmospheric. They're very likely not adversarial. They're very likely not United States. And that really only leaves technology from another kind of being. So you've got ship sightings from ships at sea going back 200 years. Right, into the 18s and maybe even 17s?
1700s, even 1600s, yeah.
You described some of these glowing objects that pop up out of the water next to a naval vessel, like as in with sails and oars.
Yep. And if the disc comes up out of water, hovers next to the ship for a few seconds, then takes off, right?
And blasts off,
there are many reports like this. Yeah. And these are coming from captain's logs and ships. Before they had a concept of UFOs, before you had a concept that there could be extraterrestrials and non-humans, yeah.
Captain's log. Pretty weird day today.
That's exactly right. Yeah, this has been going on a long time. And there's this misconception that it all started in 1947. It's this misconception that's coming from the Roswell date, basically, which captured people's attention.
And Kenneth Arnold is 47, I think.
It was the same. It was the same 2 weeks.
Wow. I forgot
that all happened, and that we had talked about in our current paper. Actually, you have a sighting rate of about 6 or 7 in the U.S. per day. Earlier in the year in 47, and then you get to late June when Kenneth Arnold happens, and the sighting skyrockets to about 250 a day for about 10 days, and then it drops again. Then it drops again.
Interesting.
It drops down to about 7 or 8. Now you can easily assume, and we discussed this in the paper, that this is a sociological phenomenon, like the drone thing that's going on right now, where you've got people panicking and misidentifying things. You could clearly assume that. However, when you look at the cases that were reported in that period of time, some of them are clearly interesting. You've got landings witnessed by 100 people of a saucer landing somewhere. You've got pilots and flight attendants from Eastern Airlines seeing a craft fly alongside their plane. This was all in the same 2-week period. And you actually had 2 crashes in New Mexico. You had the one in Roswell, and then you had the one in San Augustine's Plain, which is about 100 miles away, only a few weeks later. So all that happened. And that's why 1947 was so significant and got people's attention, because a lot happened in those 2 weeks.
And it also happens to be the year that the CIA is founded and the Defense Department.
And that's when the Air Force was founded as well.
Air Force, it all kind of gels. And then in the years that follow, there are a lot of sightings. 1952 is huge. 1957, I think, is really big. So this is not that interesting a question, but one lurking question in ufology is just like, why has it taken us so long to get from all of this sort of ambient data to a publicly accepted hypothesis that something weird is worth looking into here? Why have we not spent the appropriate resources and money and just time and attention to figure it out? As I say, it's not that interesting a question. We're finally doing it now. Do you feel like we're entering a new golden age of ufology?
Oh, I think so. Yes. Starting with the paper, the article in the New York Times,
2017
article. That was in fact, it was December 16th, the same day as today.
Oh, really?
2017. Yeah, it was exactly. Yeah, so that is literally exactly 7 years ago today. Exactly.
Ooh,
the article
got some shivers.
Oh, that's interesting. Yeah, that's kind of cool.
Our landmark interview.
So it's been 7 years. It's been 7 years, and that 7 years has made a huge difference.
So I heard you say elsewhere you thought maybe about 20 years is how much time you could reasonably expect us to take to figure out what's going on here, just from a scientific perspective.
If you've got multiple scientific groups that are funded and can actually do things, I think we could really get down to the bottom of a lot of this in about 20 years. Yeah.
So looping back to this idea of luring UFOs, is that something that you did propose or you've been thinking about?
We thought about it, and in fact, we knew that the Soviets had done this by moving, by troop movements or fleet movements in the Navy. They would actually move large numbers of ships to get UFOs to come and check them out, and then try to study the UFOs this way. So me and Matthew Shadagas at Albany were brainstorming, what can we do? We don't have any ships to move around, so what we could possibly do. Sorry, my power on my laptop's about to run out, and I didn't expect that. I was fully charged, so I don't know why. It's doing a lot, I guess. So we don't have the ability to move a fleet around, right? So what could you do? And we thought, well, if we had some kind of nuclear reactor or something, they're interested in nuclear sites, right? So what if we had a nuclear reactor? We're physicists, so this is the first thing you go to, right?
Mhm.
Which is a crazy idea. It makes us slightly worrisome. So what if we had a nuclear reactor? If we could set up a nuclear reactor and get it radiating, then what if, then maybe we could get UFOs to come and check us out. That was it's just brainstorming. Nobody, and
Sure.
so then Matthew, we're still trying to come up with what can we actually do. And Matthew
I get some plutonium, Marty.
Yeah, right. So Matthew then comes up with this idea of creating a nuclear reactor, and he said to me, I have a new idea. I have an idea to make a nuclear reactor, and he runs it past me, and he says, this is really different. This would be a whole new thing. And so he actually did this. He actually, brilliant person, brilliant idea. He came up with a nuclear lithium fission reactor.
Really? Like he invented the concept for a new kind of
invented the concept of a lithium fission reactor, and he actually made it. He got his approval from the university. He actually built it and is currently testing it. There's been a few news articles about this now.
Oh my God.
And it basically is, it takes lithium, which is a lighter element, which you don't expect to do fission with a lighter element, but he found that you can do this and it'll create tritium. The waste product is tritium, which is heavy hydrogen. It's a gas. But its half-life is 25 years or something like that. So it's a short half-life, right? So it's not going to
3 hydrogen molecules together.
Or 3, yeah. Tritium will have a proton and 2 neutrons.
Okay.
Yeah. So then it'll that's the waste product. It's not something you have to bury. It'll escape into the upper atmosphere and it'll be radioactive for 20 years or something.
Or it's potential fusion fuel, right?
Or it's potential fusion fuel. Actually, that's actually true as well. Yeah, so you could use it as fusion fuel then. So he actually created this thing, and yes, it actually works, it works to some degree. Whether can you control it well? Can you pull energy out of it well? These are the questions that he's looking into. We're not going to use it to attract UFOs. We don't. No, it was one of these brainstorming ideas, right? That actually led to a real invention. But
so now he's just interested in the nuclear.
To go create a radioactive thing that I don't want to be anywhere near that. You don't want anybody anywhere near it. And I get nervous with this thing sitting in his office.
It's in his office. It's nuclear reactor.
Physicists are nuts. I don't know if you know this. We're really crazy. No, he knows what he's doing and he's careful. He activated it and it was still active, and it stays running for, you have to activate it with neutrons. So you have to hit it with a neutron beam and gets it going. And then it runs for a little while. And he had it kind of cooling off. And he was measuring how long it takes for the radiation to die out. But it was on his radiator and it was glowing. It was glowing. I was like, no, it's not that dramatic. I'm making it sound much more dramatic. He was doing a test with the Cosmic Watch, which is what we use for radiation detection when we're looking at UAPs. And
did he at least set up a sensor array just in case?
With that. What?
Did he set up a sensor array just in case a UAP came to check him out?
Oh no, because it was in the building. It was in the building, and he's got and he has approvals from the university to do this. So he's not doing anything he shouldn't be doing. I don't want to. I'm now worried that I made it sound a little too dramatic. And
well, you made it sound really fun. I'll say that
it was fun, and that's the whole point. It was fun and exciting. I mean, that's why that's why I went into physics, was to do fun things, and that's one of the fun things that you get to encounter, and it's
nuclear reactors on your radiator.
Things like this, exactly. And
nobody touch this over the weekend.
Yeah, don't touch it over the weekend. Yeah, that's basically right.
Can I ask? Can I float an idea and see if you like it or not? I gleaned from this interview with Rich Hoffman that some of these appearances above sites like nuclear sites and military sites tended to be kind of early on in the development. Like something he said was it looks from the historic data like UAP tend to show up when there's something novel going on, and then they move on and they don't do a ton of repeat buzzes. They arrive, they check it out, and they move on.
That was the SCU study is fascinating in this respect. The activity started when they were constructing the sites to do the work with nuclear materials.
Interesting.
The nucleus activity started when they started construction, not when they and picked up again once they actually started doing the work.
Oh man!
And then it died off. Yeah,
well, that implies interesting things about either precognition or time.
Whoever is involved with these things, whatever the intelligence is they are on top of it. They know. They really, really are smart, and they really know what's going on, and they know what to look at. They know what to look for. Maybe they're well practiced in this. Who knows?
So here's the pitch based on that. Does that suggest that we maybe have a natural experiment available to us around the world at construction of nuclear sites? It's not a ton that get built in any given year. It's probably in the single digits.
There's always sightings around nuclear sites, and in fact, when Iran had problems with UFOs around its nuclear reactors when they were creating power plants, right? And around French power plants, there have been sightings, and in fact, that was true in the 1950s in the U.S. Yeah, that happens all the time.
So, does that suggest to you that these might be beneficial sites for sensor arrays? Like, if you know,
they would be beneficial sites for sensor arrays. The problem is that those are sensitive areas, and you would need proper permissions. You can't go to a nuclear weapon site and just set up your equipment. You would need the Air Force or somebody to give you permission to do that.
What about like outside the site, like at the local Wendy's parking lot?
Well, yeah, you can kind of play those games perhaps, but that would be risky, and I wouldn't recommend anything like that. It's better to do this all properly.
Yeah,
and carefully.
So, on the sensors,
you really want permissions to do what you're doing, to collect the data you're collecting, and especially on sensitive sites. I wouldn't recommend anything like that.
Okay, well, that really does leave us with one arm behind our back, doesn't it? Like we're trying to investigate this phenomenon that presumably the military intelligence community has been investigating more thoroughly than they've let on for some time, and they get to decide how much we can publicly investigate it. That's a little tough. Do you
around their sensitive sites? I mean, you don't have to. There are other places to look. There are other hot spots that we know about. The Tedesco brothers, for instance, have been, monitoring UFOs off the coast of Long Island for 2 years now, 3 years now.
And that is a bit of a hot spot. And then there's Catalina. And
Catalina's another place. There are other places in the world. Puerto Rico is also, where Algadilla is another place. Wales.
Oh, right. Wales.
Coast of Wales, near in Australia. There are many other places. Yeah.
Okay. All right.
We have plenty of places to look. We don't have the funding to get equipment built and tested to put there. That's really our problem.
Yeah. So does that seem like the core bottleneck? Like we don't even have any. It's not like you have some funding for these sensor arrays. You currently have no funding for these sensor arrays, right?
Basically zero.
And
basically zero.
One of them. Yeah. Oh man, this would be a great time for me to wave a wand made of money and solve this problem.
Yeah, it would be a great wand to have.
So, that is yet another avenue that brings us back toward this sort of squishy or social bucket of things, which is less interesting than the physics, engineering, and intergalactic cosmic sociology. But what kind of outreach do you see the community doing? Would you say Seoul is the best at this? And do you think it might be fruitful to reach out to some of the science communicators who have been, I don't want to throw too much shade, but not great on this? I was thinking about Neil deGrasse Tyson. I'm thinking about like Brian Greene, some of the guys who are, public mouthpieces of science who have been very skeptical and hesitant about this subject. Do you think it might be a valuable project to try to bring them in, to try to like recruit them and educate them on the subject, to help spread the good word?
If they wanted to be educated, they could do it any time. They contact any of us, and we
go on their shows.
Give them things to read and look at, and whatever. From what I've seen, they're rarely skeptical and mainly denialists at this point. It's and I think that's not really a very curious approach. Let's be curious. Let's look into this. Let's not be, it's good to be skeptical, but be skeptical of what you think as well.
Right. I've heard you mention that.
Of your own beliefs. The idea that nobody could come here is ridiculous. We know that that's not true. And because we're trying to go places ourselves. NASA now has a goal to get to Proxima Centauri by 2069. Right. That'll be 150 years after we invented the airplane. 150 years is all it's going to take us to get to the nearest star. Is that possible? That could very well be, but others are going to do this too. And we might not be the only ones,
Yeah.
It's one thing to be a science communicator and say, oh, the universe could be brimming with life, and then say, but it's impossible for anyone to come here. Oh, please. It's
a little convenient.
We don't actually know what's possible. And we know that's not impossible.
I've thought a lot about the psychological problem here because I think it's kind of personal. My leading theory for why we haven't gotten to a place of thinking this is likely over the last 80 years is we really don't want to. We don't want to conclude that there's something very intelligent here that isn't us.
I think that's a big part of it. And in fact, it's always been the people who have wondered what if that make the difference. Robert Goddard, read War of the Worlds, when it came out in the late 1800s, and he thought, what if I could he was launching fireworks and in the summer, and thought, what if I scaled up one of these fireworks and used it to get to Mars? What if I could go to Mars? And that led him on a path to creating the first liquid fuel rockets, which now the Goddard Space Flight Center is named after him, right? But in fact, in the 1920s, when he was doing his experiments, there was a New York Times article, an editorial from a physicist who said, well, Goddard clearly doesn't understand Newton's laws, because he would understand that there's nothing in space to push against, so you couldn't have.
Right.
It was a ridiculous editorial that the New York Times didn't retract until 1969 when we landed on the moon. Then they actually issued a retraction for that editorial, but the person who wrote it was probably dead by then. But it was, but it took that long for the mentality to change, and it's a mentality problem. It's perfectly fine to keep people grounded, but you can't look up at the stars and stay grounded in the same way. You have to be curious. So if you're going to be a science communicator, be curious at least. What are these UFOs? What did the pilot of JAL 1628 see, and what was recorded on radar? How are these things not making sonic booms? These are questions you should just be asking instead of just saying, "Oh, it's all nonsense." It's not nonsense. It's not nonsense to the people who encounter them. That's for sure. There are many experiences. Many people have had close encounters, some of them actually injured by the craft, burns, radiation sickness. You've got people who got cancer from this. I wouldn't, knowing what I know now, I wouldn't recommend going anywhere near any of these craft if they land. And so to those people, this isn't ridiculous at all. This is deadly serious. And then for, authorities to be saying, oh, this is all nonsense. Well, you don't know that it's nonsense. You don't know that. So don't be curious.
Don't write it off. Yeah. And it's profoundly unfair to the probably hundreds of thousands of people, we think, who have had experiences like this, that the rest of society.
At this point now that things have changed sufficiently that we accept the reality of UAP and the possibility that some of them may not be non-human, of non-human origin, I think there are many people that are owed an apology.
Yeah, I agree. And I think that's going to be part of this next 20 years of unfolding and discovery. looking within the UFO house, this is maybe slightly uncomfortable, but do you think your scientific colleagues have some kind of responsibility to communicate about this effectively in a way that can help raise public awareness, kind of absent
at this point, they should certainly educate themselves. Stanton Friedman used to say this: before you open your mouth, you should do your homework. And that's true for professionals as well. I mean, we require it of our graduate students. When I have a new graduate student, they have to read their literature. They have to read the literature, the scientific literature on the topic that they're going to study. And they can't talk about their work publicly until they do that. I require that of my graduate students, and I've seen graduate students kicked out of labs for not doing it. But it's okay then for a PhD in physics to go publicly talk about a topic that they really haven't studied. That's not okay, and it shouldn't be okay. They should do their homework, and that's a crude way of putting it, but I think it's an accurate way that a professional physicist would understand, or a professional scientist would understand. The kinder thing is be curious, read up on this. There are interesting cases. There is interesting data, and I welcome anybody who's interested to contact me or the other scientists working in this area to learn about this. We can point you to things to read. Yeah.
That's really great. And I think we are, as you've said, sort of opening up a new avenue. We're turning a page, whatever metaphor you'd like. This is a new day, and more information is coming to light. And I would support other people who are consuming this media and thinking about sharing themselves. I support people sharing this information and reaching out to Dr. Knuth.
Yeah, some of these things are, and maybe some of these things are atmospheric effects. Well, let's learn about those.
Right.
That's important. It's important for our pilots and for pilot safety to know what's in the air. What is in the air that they could encounter?
Whatever it is.
And whatever it is. And we should, we owe it to those people to figure out what it is, especially because we're the ones traveling to conferences in other countries, sitting in the back eating pretzels when they're encountering UFOs. And pilots encounter UFOs all the time. I mean, it happens. It's not completely rare. And in fact, I heard of a case recently where I think I won't say what airlines it was, but there was a commercial airlines with passengers in the back, 250 people in the back, and a disc flew up to the windscreen of the plane. The co-pilot freaked out and had to be restrained by the engineer.
Whoa.
And the pilot fortunately held it together. The disc hovered there for a few minutes, then dropped down and went under the cockpit, hovered under the plane. You could see the edges of it under the plane while they're flying, and stayed there for a few minutes and then left. That's all happening while everybody's in the back watching The Matrix on the little TV screens, right? I mean, and you're, and we're waiting to use the bathroom in your plane. But this is what's going on in the cockpit. And thank God that the pilot held it together. But those pilots need to know what's in the air. They need to know what they're encountering. They need to know if this is safe or not. And, and so you've got UFOs that are coming within 50 feet of airplanes, and the pilots recognize this and are trying not to panic. That's the recipe for disaster. You're going to end up with a crash. That's what's going to happen.
And then on the other side of that, they don't have a place to report this. There's no pipeline.
No, and if they do report it, they're going to get their license taken away or get fired.
They have an active disincentive.
It's a really, really dangerous situation.
So there's a bottleneck between people who are seeing these objects and the rest of us who like at least half of America doesn't think that this is a common occurrence. They just have no idea.
Yeah,
so
it does happen, yeah.
That's another bandwidth issue. We need a reporting system of some kind. And NASA volunteered their systems as part of their report last year.
Pilots ought to be required to report these things.
Yeah.
It ought to be a requirement, and there should be punishments if you don't. I mean, that should be the other way around.
Right.
Really
My loose understanding of this is that the Congress actually tried to pass some legislation about this, and this could be just rumor, but what I heard was that the intelligence community didn't want that to happen. I don't know, and that's too vague.
That's hard to know. I've heard rumors like that, and I'm not sure what to make of some of them. Yeah, but
so moving toward a landing here, so to speak. I'd love to ask you about kind of the weirdest edge of this thing, which I feel might have something to do with communication, and see if you have any instincts about how / whether we should attempt communication, what you might like humanity to say. If you have intuitions about sort of the avenues we might attempt to pursue on doing that, that would be cool. But I'm also just curious about how you feel about the general idea of reaching out and saying hello and establishing some kind of diplomatic, or at least in some way public relationship with the NHI.
Well, that's interesting. So we're jumping ahead a good bit through several assumptions, and I just want to be clear about that. So we're assuming that there are craft in operation that are NHI origin, non-human origin.
Right.
So assuming that. Now what? And while we do have some evidence for this hypothesis, this is not what I would consider proven as a scientist. I want to be clear about that.
Agreed.
So at this point, if that's the case, then I think communication is reasonable, because clearly somebody is here. If you're assuming that's the case, then there somebody is here, and they've been here, and very possibly throughout human history, right? It really could just be that we're just becoming aware of this fact.
Yeah.
And so I think communication's reasonable. I don't know how you would proceed to do it. And there's many ifs here, and this is one of the problems. You could take the whole route. Well, like SETI does. Well, if we detect something, then how do we communicate with them? And there should be some kind of official response. And you can worry about that sort of thing. However, if the situation is that you've had, and I'm nervous to talk about this as a scientist, because we don't have a lot of proof of this, that. But if the abduction problem is a real problem, and it really is a non-human issue. So if people are being abducted by aliens, I'm saying, if that's the case, then communication's already happened. Communication's happened, thousands of times already.
Yeah.
So then in some ways it's a non-issue. So
that's why I use the word public. I think about it as public first contact. Like we probably had hundreds of thousands of contacts.
First contact probably happened a long time ago, if that's the case.
If that's really what's going on, so but what we've never had.
If that's what's going on. So what we really need is we need to figure out what's actually going on. We need to figure out what these things are, how they work, where they're from, who made them, who's responsible, what their interaction with humanity has been, if any, and that all needs to really be established. And I think you can't really make any, you can't really come up with any decisions on what to do officially until you officially know to some degree with evidence what the situation actually is.
Yeah, part of what I'm thinking here is that we can get pretty far probably analyzing this stuff from the outside, but we're not necessarily going to get final answers about points of origin and engagement with our species historically until we can directly interface with these things.
If they're non-human controlled, we have to somehow interface with the non-humans. Yeah.
And we have to find a way to do that publicly.
They're not doing it. If they are non-human, they're not doing it in the way that we would.
Yeah.
How would we do it? Well, you hear it all the time. You would land on the White House lawn. I don't know why the White House is so the important place to go.
But no way we would do that. No way we would land on the.
Nobody would do that. We wouldn't land. We wouldn't actually even do that. No.
Yeah.
You'd be better off landing in a farmer's field and talking to a farmer, which is more like what happens actually. It's a safer thing, certainly a safer thing to do. Landing on the White House lawn is not safe, and if anybody's been studying us, that would be the first thing they'd know. That is not the safe place to land. If these are non-human origin, they've been studying us for a long time, and they know us quite well. especially if they're showing up at nuclear facilities while the construction's happening. Construction of the facility is happening. That's very strange and shows it really is indicative of careful and intelligent surveillance, which is then concerning. I mean, it tells us a lot about them, actually. But the fact that they then haven't communicated with humans in an official manner, in a public way, also says something about them. They're also not trying to hide. They have bright lights on, some of them hundreds of megawatts. I mean, I don't know why you would need lights so bright.
Right.
In some cases. So they're not trying to hide, but they're not publicly landing and saying hello either.
My brother and I have called this the kind of careful problem. We can see them. They're not hiding completely, but they're not landing on the White House lawn. What accounts for this sort of medium approach that they're taking? Are they gradually warming us up? Are they just not that concerned about us viewing them?
It could be both, yeah. And I've heard, scientists liken us to ants. Well, they're like interacting with us like we would with ants. I'm like, I don't think that's real either. And ants are interesting. I mean, whenever I hear people talk about comparing us to ants, and I can only think what an entomologist would think. An entomologist would think, ants are cool. Ants are amazing. Why are you belittling ants?
E.O. Wilson built a whole career on ants.
Yeah, E.O. Wilson. Yeah. Ants are amazing. And they're clearly would be interested in us and are interested in us. And clearly that's the case. And so,
it's fair that we're returning the favor by being very interested in them.
We should be interested in them. And
Well, thank you so much for sharing your time today, Dr. Knuth. Can I ask where people should follow your work online and look to pursue your research in the next few years?
Check us out at UAPX, at our UAPX website, UAPX Expeditions, UAPXpeditions, I think it is .com. I don't actually know our website name. No.
People can Google, yeah.
UAPX, or you can check out any other groups as well, SCU, SUAPS, Sol, Galileo, IFEX, Vasco. There are a lot of, and we all talk to each other and know each other quite well. So it's all very good.
Well, that's great. Maybe in a couple of years when we get a little more information or you publish another paper, we could have another conversation and take this farther down the road.
I'm hoping that our large paper on the history of, or the new scientific study of UAPs, which is the paper, that will be coming out this year, hopefully. And so
this year, 2025?
It should be this year, 2025. Yep.
Nice. Okay. Well, I will let you go.
Like 150 pages long, plenty to read. A good thing for the science commentators who want to learn more to read. That'll be a good paper to look at.
Oh, that's a good point. So everybody listening, educate yourselves and hand this to your favorite science communicator so they can get up to speed on this fascinating topic. I will let you get back to your rest, Dr. Knuth, but thank you so much for your time today. And it was a pleasure speaking with you.
Yes, pleasure speaking with you too. Thank you for having me.
And that's the show. Thank you for watching or listening. Support us for $1 a month at patreon.com/WTUFO, patreon.com/WTUFO. Support us for $1 a month. Thank you very much.